Select the major product of the following reaction. So if we look at this reaction, we see that we are starting with an aromatic nitrile. And we know that we haven't seen reactions of an aromatic ring yet, so we are probably going to be considering what's taking place with this nitrile. And so let's take a look and see what we are reacting it with. So we see that we have this propyl magnesium bromide. So this is an organometallic reagent. So specifically, this is a Grignard reagent. And we know that Grignard reagents are very strong bases and also very strong nucleophiles. So the first thing we would look for is if we had an acidic proton, because it's going to act as a base first of all if there's an acidic proton available. But we don't really see any here. The only hydrogens we have are on that benzene ring attached to sp2 hybridized carbon, so those are not acidic. So it is going to act as a strong nucleophile, and we can almost consider this, so we can consider this as a ionic bond rather than a covalent bond if we want. And that might make it a little bit easier for us to visualize exactly where our nucleophilic carbon is. So that carbon that's attached to the magnesium, you could consider that really being like a carbanion. And the magnesium bromide being the positively charged counterion. So what we can envision here is that this bond, or that lone pair if you like, will attack any sort of electrophilic atoms, so electrophilic carbons. So what we have here is the most electrophilic carbon we have is the one that is part of that nitrile. So we have seen lots of electrophilic additions to carbonyls and carbonyl-like compounds, and this is going to follow the same pattern. So we are going to attack the carbon of the nitrile and push that lone pair of electrons up onto the nitrogen. And so what we get there as an intermediate is we are going to have a carbon-nitrogen double bond because we removed one of those pi bonds. That nitrogen will now have an extra lone pair of electrons in addition to the one it started with, so this has a negative charge. And we have formed a new carbon-carbon bond between this carbon of the propyl chain and the carbon of the nitrile. So we can add that propyl chain on. And so when we've done these additions before, we've always wanted to look at our intermediate and say, can those electrons come back down and reform a pi bond and kick off a leaving group? And so we want to look at what we have attached to this carbon, and we see that we have another bond to carbon of that benzene ring and the bond to the carbon of the propyl chain. So we do not have a good leaving group in here at all. So this is just going to sit until we add in our H3O plus. And in this aqueous acid, we are going to protonate completely that nitrogen. And so what we see at this point is that we have an iminium ion, or another way of thinking of that is a protonated imine. And this is hydrolysis conditions. So we should remember that imines can be hydrolyzed to give you carbonyl compounds. And so to figure out the product of this imine hydrolysis, I have grabbed a pencil. This is what's going to take place in the next step, is a hydrolysis. So we have that phenyl ring, we've got the double bond to the nitrogen, and we've got the propyl group that we added. And so, and we missed a carbon atom there. And so when we do this hydrolysis, we want to recognize is the carbon that has the double bond to nitrogen, when you hydrolyze it, it's going to become a carbonyl, and the nitrogen is going to become an amine. So when we do the hydrolysis, we're going to break that bond. This is going to get a carbonyl. This is going to get another hydrogen, if not two, to become the ammonium. But the key part is what we're forming here. So we should recognize when we straighten that out and get the right bond angles that we're going to end up with this ketone. So where that oxygen is what was the carbon of your nitrile, and the carbon chain that you've added is coming from your Grignard reagent. So this is option A.